Okay, so I started recording this class and then I will post it on the Peachboard. So could you please once again confirm if you hear me and you see my screen?
Yeah.
Yes.
Okay, that's good. Okay, so in the previous class, we started the discussion of the mesh current method. And let me remind you with some steps or issues related to the mesh current method. So the first thing you need to do is to check whether the circuit is planar or non-planar. So if you can draw the circuit on a plane, on a paper or on the screen, and there will not be any two lines that intersect each other or going on the above of each other, then the system will be planar or the circuit will be planar. In case the circuit is planar, you can use the mesh current method. But if the circuit is non-planar, and we had some examples on non-planar circuits, then you cannot use the mesh current method and you need to use another technique or another method. So far, the mesh current method is the second method that we are learning. So we are done with the node voltage method. And for the node voltage method, you can use it no matter the circuit is planar or non-planar. But for this method, you need to make sure that the system or the circuit, the given circuit is planar. Then after you make sure that the circuit is planar, you need to identify the number of meshes in the circuit. And the number of the meshes in the circuit can be calculated as the essential branches, the number of essential branches minus the number of essential nodes minus 1. So for node voltage method, you need n essential minus 1 as a number of equations, but here we need essential branches minus essential nodes minus 1. Once you identify the number of the meshes, you assign mesh currents, and you can assign them as in each mesh. In each mesh, you assign a mesh current that will flow in the perimeter of the loop or the mesh. And you can assign them as IA, IB, IC, and so on, or you can assign them I1, I2, I3, and so on. And the direction of these currents, of these mesh currents, should be the same. So if you assign them in a clockwise direction, so all of them should be in a clockwise direction, or all of them should be in the counterclockwise direction. So for our course, let's assign them always in the clockwise direction. So we will be on the same page with the textbook and with the examples that we will solve. And we had, I guess, 1 or 2 examples in the previous class, and you had been asked to solve the homework. And I thank many of you students that already solved and submitted the homework on mesh currents. So thank you for your proactivity. Okay, so today we will continue the discussion, and actually we will have more examples with some special cases, and then in the second part of this lecture I will solve some problems on mesh current method. So here we have the mesh current method when we have dependent sources. So as you see in this circuit, so we have 1, 2, 3, 4, 5, 6 elements, 6 circuit elements in this circuit. We have 1, 2, 3, 4 essential nodes. So if we need to solve this using a node voltage method, so we will have 3 equations because the number of essential nodes are 4. 1 should be selected as a reference, and then you will assign V1, V2, V3, write KCL for each non-reference node, and then you solve the equations. For mesh analysis, we need to see how many essential branches we have here, And the essential branch is that branch that connects it to essential nodes without passing any essential node. So we have one essential branch, 2, 3, 4, 5, 6. So the number of essential branches here is 6. Number of nodes minus 1 is 3. So 6 minus 3 will be 3. So the number of equations, if I want to solve it using mesh current method, will be 3 equations. So it will be the same as the nodal voltage. But of course, if I have the choice, I will go with the node voltage, because once I will select this node as a reference, this voltage will be known, because we have a special case here when you have a voltage source which is connected between essential nodes. But since we are studying the mesh current method, we will solve this using the mesh current method. So this method is different from the previous ones in the previous class, in that we have a dependent voltage source, but it's fine. You see that you have a controlling variable, which is I phi in this example. So what we need to do is to represent this controlling variable through the mesh currents, the assigned mesh currents, and we will see this after a minute. Okay. So we need to use the mesh current method to determine the power dissipated in the 4 ohm resistor. And where is the 4 ohm resistor? Here it is. So we need to find the current in this 4 ohm and then find the power. So any questions so far? Is it clear so far?
Yes.
Yeah.
Okay. So the first thing, we identified the number of meshes, and then we assigned mesh currents. As you see here, we assigned I1, we assigned I2, we assigned I3. And after we assign the mesh currents, we need to write KVL for all meshes. And we will start with this one, left-hand side one. So if I write KVL and I will start with the 50-volt voltage source, we are writing KVL in the clockwise direction. So for the voltage source, you are going from negative to positive, and this is voltage rise, and voltage rise will have negative voltage. So it will be negative 50, but negative 50, when you bring it to the other side of the equation, it will be positive 50. Okay, so let me write here, when you go in the direction of, let me write here, let me see why I can't write it. Okay, I'm not sure why I cannot write it, but when you go from the voltage, from the negative side to the positive side, it will be voltage rise, and voltage rise is negative. Okay, so I will check with my pens later on. Okay, and as you see here, we need to write the voltage drop in 5 ohms, so it will be 5 times the current which is flowing in this 5 resistor. So the current which is flowing in this 5 in the clockwise direction will be I1 minus I2. Do you see that the current is I1 minus I2, please? All of you, do you see that the current is I1 minus I2?
Yeah.
Yes.
Okay, so it will be 5 times I1 minus I2, and then I have the last current, which is 20 times the current which is flowing downward, and the current flowing downward will be I1 minus I3. I1 is going like this, while I3 is going upward, so it will be I1 minus I3 times 20. So this is the first equation. I can rewrite it. So this is 50. I have 5 I1 and 20 I1. It will be 25 I1. I have negative 5 I2, and I have negative 20 I3. So we rewrite the equation here. Okay, the second mesh is this one. So let me start with the 5 ohm resistor. So in the 5 ohm resistor, the voltage drop is 5. times the current which is flowing in the direction of the mesh current. So the current in 5 will be I2, and we see that this current is going in the opposite direction. So it will be I2 minus I1. So it's 5 times I2 minus I1. For the 1 ohm resistor, we have only one current, and this current is I2. So it will be 1 times I2. And in the 4 ohm resistor, we see that the current I2 is flowing in the 4 ohm resistor, and we have another current that's flowing in the opposite direction, which is I3. Then we need to have 4 I2 minus I3. So this is the equation for the second mesh. We don't have any voltage sources, so the other side of the equation will be 0 according to KVL. So this is 0 here. It is, we have negative 5 I1, so it is negative 5 I1. We have for I2, we have 5 I2, 6 I2, and 10 I2. So we have 10 I2. For I3, we have negative 4 I3, so it is negative 4 I3. And the last mesh, which contains the voltage dependent source, and this voltage source is current controlled because it is represented through a current. So, and here we will start with the 20 ohm resistor. So in the 20 ohm resistor, I3 is flowing, and in the opposite direction, we have I1 is flowing. So it will be 20 times I3 minus I1. Then in the 4 ohm resistor, we have 4 times I3, but I2 is flowing against I3. Then it will be 4 I3 minus I2. And here we are going in the direction of voltage drop from the plus to minus. And if you go in the direction of voltage drop, it will be positive. So it will be plus I15 I5 plus this voltage, and this voltage is 15 I5. So make sure that you understand that this is a voltage. Also, it is given in terms of a current. Okay, so now we need to represent I5 in terms of the mesh currents. So I will look in the circuit. Where is I5? Here it is I5. So I5 is the current which is going downward. And the current is going downward is I1. And we have against it I3. So I5 is equal to I1 minus I3. So I5 is equal to I1 minus I3. And now I will put this value here. So again, I will collect the numbers. So I have negative 20 I1. And here I will have 15 I1. So it will be negative 5 I1. I will have negative 5 because 20, negative 20 plus 15, it will be negative 5. For I2, I have here negative 4 I2. So it will be negative 4 I2. For I3, I have 20 I3. And I have 4 I3, it will be 24 I3. And then I have negative 15 I3. So 24 and negative 15, I will have 9 I3. So now I have 3 equations, and they are rewritten and ready to be solved. So you can find I1, I2, I3. So in this case, I2 is 26, I3 is 28. The author didn't find I1 because he is not interested in its value, because we need to find the power in this 4 ohm resistor. And in order to know the power, you need to multiply this 4 by the current square. And the current here is I2 minus I3. So I1 here wasn't found, but of course you can find it. You can find it. So the power in the 4 ohm resistor will be the current, which is I3 minus I2 square times 4. It is there is no difference whether you are taking the current in this direction or the current in this direction. So you can say I3 minus I2 or I2 minus I4 in case you are calculating the current, because at the end of the day, you are taking the square value of that current. So the either this direction or this direction will it will give you the same number times 4. So it will be 26 or 28 minus 26. It will be 2. 2 square. It will be 4. 4 times 4. It will be 16 watts. Any questions on this, please? Any questions on this example, please? Is it understood?
Yeah.
Yes.
Okay, let me see now. Okay, now I can write it. Okay, once we don't have questions, I will go to the next slide. And on the next slide here, we have examples. So at the end of this lecture, I will solve this example for you. Okay, I will solve this one, but let's have a look at this one. So in this one, how many simple circuit elements I have? Quickly, please.
6.
6. How many essential nodes?
4.
4.
4. How many resistors?
4.
How many independent sources?
1.
How many dependent sources?
1.
How many essential branches? Essential branches.
6.
6, exactly. So how many meshes in this circuit?
3.
3. Is it planar?
Yes.
Yes. Okay, then what we need to assign 3 currents. So we can assign this one and this one and this one. So 3 currents. So you need to write the 3 kVL as it was in the previous circuit. So what is the difference between this and the previous one? So I see 4 resistors, voltage source 5i5 and 25. So I don't see any difference. So let me go back to see the previous one. So we had the same structure, almost the same structure, but the controlling value here, the current was in the middle, but the current here is in the this mesh. As you see, I5 is here. So what do you think? It is simpler or more complex compared to the previous one?
More complex.
Okay, in the previous one, what was I5 equal to? I1 minus I3, right? Because it is here, right? Do you see I5?
Yeah.
Okay.
Yes.
But in this, what will be I5 equal?
I1.
I1. So it will be simpler because even I don't need to substitute this value here. You can write immediately that it will be 5I1. 5I1 because I1 in this mesh is equal to I5. So I see that this circuit is simpler than the previous one in terms of representation of I5. So I5 will be equal to I1 while I5 here is equal to I1 minus I3. Okay, so this is the circuit. So I hope you will do it by yourself, but we will do in the end of the class, we will do this one. Okay, so let me go. So what special cases we may have? What special cases we may have? Of course, we in the node voltage method, if there was a source, voltage source, which is connected between two nodes, essential nodes, and none of these nodes were selected as reference. So we had a problem that we cannot represent the current which is flowing through the voltage source. And so the solution was to use what's so-called a supernode, and supernode merged two nodes between which we had the voltage source, and then we bypassed the voltage source, and the third or the last equation was written from inside the supernode. And here we have the same issue. So as you see at this circuit, we have the same circuit, we have voltage sources, we have resistors everywhere, but we have here in one of the essential branches, current source. We have current source. And as you remember that mesh analysis is based on writing KVL. and KVL is composed of voltage drops, So I can write the voltage drop in this voltage source, it is 100. While I'm going up, it will be negative 100, as you see here. I can write the voltage drop in this resistor as a 3 IA minus IB. I can write the voltage drop in this 6 ohm resistor as 6 times IB. But what is the voltage drop across the current source, which is 5 ampere? So I know the current 5 ampere, but I don't know by which I need to multiply this 5 ampere because I don't see any resistances in this branch. So I don't know what to do, how to write the voltage drop across the 5 ampere. So to solve this problem, if you have a current source that is connecting to non-essential nodes, essential nodes, that is connecting to essential nodes. So you need to avoid it, to pass it, and to form a super node. And as you see, this mesh A has this problem, and mesh C has this problem. So then I need to make a super node that is merging mesh A and mesh B. So I have a question in the chat box, so let me read it. So we replace the dependent source with a short essentially for the super mesh. I didn't understand we don't have dependent source here. All the sources are independent, but maybe you are indicating the current source. We will see. Okay. So is it clear for all of us? Okay, that's good. Okay, so it's clear for all of us the 3 meshes that we identified or we assigned in this circuit.
Yeah.
Yeah, clear to me. Yeah.
Okay, so the problem that when we are writing KVL for mesh A and KVL for mesh C, we will not be able to express the voltage drop across this current source. So what we need to do is to keep mesh B as it is because it has no problem, and we can write mesh B, while mesh C and A will be combined in one mesh, which is the super mesh, as if you are removing the current source. As if you are removing the current source, then you will have one big mesh that combines mesh A and mesh C in it. And you still have the currents indicated as IA and IC. So now let's write KVL for the super mesh. So 100, we are going in the direction of voltage rise. So voltage rise, if you are going in the direction, if you are going in the direction of voltage rise, it will be negative. If you are going in the direction of voltage drop, it will be positive. Okay, so we are going with IA in the direction of voltage rise from the negative to the plus to the positive side. So it will be negative, so it is minus 100. So the voltage drop in this 3 ohm resistor will be 3 ohm times IA minus the IB, because IB is also flowing in a 3 ohm resistor. So it will be 3 IA minus IB. The voltage drop in this 2 ohm resistor will be 2. Now we need to have IC, because in this 2 ohm resistor, IC is flowing, not IA anymore. So IC minus IB. So we will have 2 IC minus IB. And then this voltage source in the voltage drop, so it will be positive 50. And then in this 4 ohm resistor, I have IC alone. So it will be 4 IC. And in this resistor, I have IA alone flowing in it. So it will be plus 6 IA. So remember that IC is not going here and IA is not going here. So IA in its mesh and IC is in its mesh. So these 3 components will be represented through IC. These 3 components will be represented through IA. Is it clear, KVL, for the super mesh?
Yes.
Yeah.
More responses, please.
Yes.
Okay. Okay, I see only 6 students are following me. What about the other, please? Okay, I
Yes.
see now. Okay, thank you. Okay, I see my response. Okay, now we need to write the KVL for mesh B, and B has no problem. So it will be 10 IB plus 2 IB minus IC plus 3 IB minus IA. And this will be equal to 0. So 0 is equal to, sorry, 3 IB minus IA plus 10 IB plus 2 IB minus IC. So now we have two equations. One equation from mesh B, the other equation, the big one, is from the super mesh. But I need 3 equations because I have 3 unknowns. So the third equation, please listen to me, all of you. The third equation is there inside the source, that you remove. So I will look to the source that I removed. It says 5 amperes goes up, and the current which is going up is IC minus IA. So 5 will be equal to IC minus IA. This is the third equation. So always, please remember, whenever you are using super node in node voltage analysis, or you are using super mesh in mesh current analysis, you need to take the third equation from the source that caused the problem. So inside that super node or inside that super mesh. So this will be the third equation. Now we have 3 equations with 3 variables, IA, IB, IC. Solving these 3 equations, you will have IA is as much, IB as much, and IC as much. Any questions, please? Any questions? Okay.
No.
Okay, now we are done with 2 methods so far, which is node voltage method and mesh current method. So we need to see how they are, how we need to select the method if we have the choice to use any method to solve any circuit. So we will see when the node voltage method is preferred, or vice versa, when the mesh current is preferred. And so we need to ask 4 questions, and based on your answer, you can use which method. So does one of the methods result in fewer equations to solve? So of course, if one method has 3 equations, the other method has 4 equations, I will go with the 3 equations. So the lowest number of equations is better, because you will have lower, let's say, mathematical manipulation. Does the circuit contain supernodes? If the supernode is difficult for you, so I will see whether I have a supernode, then I can go to the mesh analysis. If so, using the node voltage method will permit you to reduce the number of equations to be solved. So you will have 2 equations, and the third one is from the supernode, from inside the supernode. Does the circuit contain supermesh? And if so, using the mesh current method will permit you to reduce the number of equations to be solved. And the last question, will solving some portion of the circuit give the requested solution? So what does this mean? So for example, if the examiner will ask me, find the current in that resistor. So of course, I will go with mesh analysis, because he asking about the current. So once I solve the equations and find these currents, I may find the current directly. Or if the question is, what is the voltage across that resistor? So then I may go with the voltage analysis, because the solving portion of the circuit maybe will give me the answer. If so, which method is most efficient for solving just the related portion of the circuit? Okay, and I will add to these 4 questions that whether the circuit is planar or non-planar. If the circuit is non-planar, I can't use a mesh analysis. So the four questions, the previous four questions, you will ask them if the circuit is planar, because if the circuit is non-planar, you don't have the choice to select mesh the current method to solve the circuit. And here we have, in the last slide, we have three circuits. So we have, as you see, to be solved using mesh analysis. I will do this one with you all, guys. And here we have a special case when we have one mesh, and as you see in this mesh, we have a current source. So this will reduce the number of equations. Here we have the same as the one we solved, and here we have also one mesh. So this mesh, the current of this mesh is known and is equal to -10, because you need to go in the clockwise direction. And this current is known as well, and it will be equal to 2V over 5. And we will see, and here we have one current source that you need to use a super node that will combine this mesh and the upper mesh. So your super node will be this one. Let me assign the super node. So this will be the super node. So you will have one super node equation with two assigned currents in this direction, and one equation from the this mesh, and then from this current source you can get the third equation. Here we will have one equation, we will have another equation, and the third equation is known. So here you will have even one equation because this equation is known as well. Okay, then I will solve the first one where we have one equation. Second, the third one is known. So we will have two equations with two unknowns. Any questions, please? So I will solve this one, and I solve one from the previous slide. And then you try to solve these two. If you do these two, you will be able to solve any given circuit in mesh analysis. Okay, any questions, please? Okay, then let me go to the whiteboard. Okay, so let me go to the whiteboard, and I will start with one example to solve. Okay, so let me draw the circuit first. So we have a voltage source, dependent voltage source, and before that we have a resistor, and then in here we have one resistor, and the other side we have another resistor. We have a connection like this, and then we have voltage source. We have a resistor with a voltage source. And here we have this connection like this, and then we have a resistor. And this voltage source is a plus minus. And now I will give the values. So what do you think? How many meshes we need? How many meshes we need?
3.
3, right? Thank you. Okay, so it seems that I have all the parameters here. So what we need to do is to solve this circuit and to find the power of the independent of the dependent voltage source. So we need to find the power here in this element. Okay, so as I see, I have many resistors. I have two voltage sources dependent. I have one independent, sorry, and I have one dependent voltage source, and this dependent voltage source is voltage controlled, and this is the controlling value with its polarity. So everything for me is clear. I have four essential nodes. So using node voltage analysis, I will need three equations. One of them is will be known, V1, it will be equal to 25. So I need only two other equations. So node voltage analysis fits more here, but I need to use mesh analysis to solve it. I have 1, 2, 3, 4, 5, 6 branches. So 6 branches minus 4 minus 1, it will be 3 meshes. So I need 3 meshes to solve this circuit, and I will assign them as I1 and I2 and I3. So I will assign the meshes in the clockwise direction, all of them in the clockwise direction. And now I need to write KVL for all of them. So I will start with mesh 1, then mesh 2, then mesh 3. So I will start with the voltage source. So please look to the voltage source. It will be negative or positive, the voltage source.
Negative,
Negative, why?
because the current's going through the negative side, the voltage rise.
Okay, thank you. So now the 2 ohm resistor, what is the current in the 2 ohm resistor?
I1 minus I3.
I1 minus I3, thank you so much. And now the 5 ohm resistor, what is the current in the 5 ohm resistor?
I1 minus I2.
I1 minus I2, thank you so much. And what about the 10 volts, positive or negative?
Positive.
Positive. And this is equal to 0. So this is the first mesh. So again, we are going in the clockwise direction. I started with this voltage source. So I'm going in the direction of voltage rise. So it will be negative 25. And then the voltage in this 2 ohm resistor. So 2 times I1 minus I3. And then the voltage across this 5 ohm resistor. So it will be 5 times I1 minus I2. And then I'm going in the voltage drop 10 volt, it will be plus 10 equal to 0. Excellent, thank you so much. So can another student please give me the second mesh, and I will start with this voltage source. So this voltage source, negative or positive?
Negative.
Negative 10. Okay, thank you. Plus the current which is in 5 ohms resistor.
I2 minus I1.
I2 minus I1. Thank you so much. The current in the 3 ohm resistor.
I2 minus I3.
I2 minus I3. Thank you. And the current in the 1 ohm resistor.
I2.
I2. And let me multiply 1 by I2 so it will be clear for all of us. Okay. And this is equal to 0. So this is the second mesh. So I started with this voltage source and I'm going in the direction of voltage rise. So it will be negative 10. Then the voltage drop in this 5 ohm resistor, it will be 5 times I2 minus I1. So 5 I2 minus I1. And then this 3 ohm resistor, it will be 3 times I2 minus I3. So 3 I2 minus I3 plus, and here I have only one current is flowing downward, which is I2. So it will be 1 ohm times I2, and this is equal to 0. Okay, one more students, please, for the third mesh. And we will start with the dependent voltage source. So the dependent voltage source, we are going in the voltage rise or voltage drop.
Voltage rise.
It will be negative or positive?
Negative.
Negative. Then I will do negative. and its value is given as negative 3 V5. So I'm taking negative of its value, and its value is given negative 3 V5. Okay, now the current in the 14 ohm resistor, what is?
I3.
I3. And what will be the current in the 3 ohm resistor?
I3 minus I2.
I3 minus I2. And lastly, the current in the 2 ohm resistor,
I3 minus I1.
I3 minus I1. Thank you so much. And this is equal to 0. Okay, so now I have the 3 mesh equations. I have one unknown, second unknown, third unknown, and I have 1/4 unknown. So I need to get rid of this V5. So what do you think? What will be V5 equal in terms of the mesh currents? What will be V5 equal in terms of the mesh currents? So here is V5. As you see that V5 is the voltage drop across the 3 ohm resistor. According to Ohm's law, any voltage drop in a resistor is equal to the resistor times the current flowing through it. So V5 will be equal to 3, which is the resistor value. And now,
I2.
say it again, please.
Is it I3 minus I2?
Okay, but you started from this negative sign, and according to the positive
All
sign
right.
convention, we need to start from this sign.
Oh,
So
okay.
what?
Very
So what?
I2 minus I3.
I2 minus I3. Thank you so much. So this is the voltage V5. So V5 here, according to its polarity, I'm multiplying the 3 by the current which is flowing from the plus to the minus, because passive sign convention. The current which is flowing in this direction is I2, since I2 is going like this, minus I3. So it will be I2 minus I3. Now I will take this value, 3I2 minus I3, and plug it here in the place of V5, sorry, V5. Okay, now I can rewrite the equations. So I already rewrote the equation here. I have them. So let me rewrite them very quickly. So I will have 7I1 minus 5I2 minus 2I3 equal to 5. The second equation is minus 5I1 plus 9I2 minus 3I3 is equal to 10. And the third equation will be minus 2I1 plus 6I2 plus 10I3 is equal to 0. So now after I had plugged this value here, so now I have only 3 unknowns, I1 and I2 and I3. So solving these 3 equations, we will have the following answers. I1 will be 4 amperes. I2 will be 3 amperes. And I3 will be negative 1 ampere. So these are the answers if we solve the question. Okay, so the question is, what will be the power delivered by this source? What will be the power delivered by this source? So I need to find the power delivered by this source. So as you see, the current, the power in general, power is equal to VI. Once it asks me what is the power delivered to this source, or what the power absorbed by this source, so we need to apply the passive sign convention. So in the passive sign convention, as you see, current I3 is flowing in this direction. So from the negative to the positive. So this means that I will have a negative sign. I will have a negative sign because the current is flowing from the negative, not from the positive. So P in this case will be negative because we don't have the passive sign convention applied here. So the voltage is by itself is 3 V phi, and V phi is 3 minus I2 minus I3, sorry, 3 times. I3. So this is the voltage, and this is multiplied by the current, which is, as you see, the current is I3 multiplied by I3. And if you plug the numbers, it will be negative 36 watts. So the power delivered to this source is negative 36 watt, which means this source is delivering, giving us 36 watts. Okay, so this is one example that I wanted to solve for you. And as you see here, we have one dependent source. Now I want to solve another example. So please have a look and let me know if you have any questions in this example.
Just one quick question for equation 1 in the blue.
Yes.
It's supposed to
This
be
one.
equals 15. Instead of 5.
It's equal to 15, right?
Okay. Just making
Thank
sure.
you
Thank you.
so much.
Nope, no
And
problem.
I do have it 15. Yes, I do have it 15. So it is equal to 15. Thank you so much. Any more questions, please? Feel free to ask any questions, please. No more questions? Okay, how much confident out of 10 that you can solve such a circuit? So I see 8, 8, 8, 8, 9.5, 8, 8, 8. Okay, that's great. That's great. Because if you can solve this problem, you can solve any given problems, because here we have either both dependent and independent sources, and we have 3 equations and so on. Okay, so let me go and solve one more example, and this will be our last example in mesh analysis. So the circuit, let's have it in red. So we will have one current source, and then a resistor, and another resistor, another resistor, okay. So and we have another resistor here. Okay, now let's have the values in green. So here we have 30 volts. Here we have 3 ohms. Here we have 8 ohms. And here we have 6 ohms. Here we have 4 ohms. 2 ohms. And here we have 5 ohms. The current source is 16 amps. And I think that's all. So 16 amps, 5264, 5264, 8330. Okay, so this is the circuit. And as you see, we have 1, 2, 3, 4. So as you see, we have 4 essential nodes. We have more nodes, of course. We have here, we have 1 non-essential node. Here we have 1 non-essential node, right? So we have, as you see, 1, 2, 3, 4, 5, 6 nodes. 4 of them essential nodes, because in these 4 we have 3 components connected to each node, while these nodes only 2 components. So these are not essential, while these are essential. So if you choose the node voltage analysis, so one of them will be reference, this one or whatever, then you will have 1, 2, 3 voltages to find. So it will be 3 equations with the 3 unknowns. While here we need to use mesh analysis because our lesson is mesh analysis. So, and I see the first thing that I need to double check that the circuit is planar and this circuit is planar. And now I will see how many essential branches I have. So this will be 1, this will be 2, this will be 3, this will be 4, this will be 5, and this will be 6. So essential branches, B essential, is equal to 6. And the essential nodes is equal to 4. And then the number of equations in mesh analysis will be 6 minus 4 minus 1, and this will be 3. So I have 3 equations. I need to have 3 equations. So here we have a special case. Here we have a current source that is connected between 2 essential nodes, and that is in the perimeter of a mesh. So it is not in between 2 meshes. So if it will be here or here, it will be another issue. So then you need to use a super mesh. But once this current source is in the perimeter of the mesh and it is not common with another mesh, then this is a special case that it will reduce the number of equations for us. So let me assign the meshes. So I have in the chat box, so Travis says that I3 is equal to negative 16 ampere, and this is correct. So let's see how is that. So I will assign the first one and I will call it I1. I will assign the second mesh and I will give I2, and I will assign the third mesh as I3. And now I need to write the KVL for the 3 meshes, but once I see that I3 is equal to the current source that I have, but since they have an opposite direction, so I can directly say that I3 is equal to negative 16 ampere. And once I have I3, then I don't need the 3 equations, I need only 2 equations, because the unknowns will be only I1 and I2. Is it clear for all of us? Is it clear what I'm saying?
Yes.
Yes.
Okay. Okay. So let's now start and solve or write KVL for the first mesh, and who will help me starting from the 3-volt source. So anyone please help me, and I will start with the 30-volt source. So we are going in the direction of voltage rise, so it will be positive or negative?
Negative.
Negative 30. Okay. And then the 3 ohm resistor, what will be the voltage drop in the 3 ohm resistor?
3I1.
3I1, thank you. What will be the voltage drop in the 2 ohm resistor?
2 times I1 minus I2.
Excellent, 2 times I1 minus I2. And what will be the voltage drop in the 6 ohm resistor?
That will be 6I1.
Excellent, 6 I1 equal to 0. This is the first mesh. The second mesh, please, anyone else? I will start with the 2 ohm resistor. Or let's start with the 8 ohm resistor, the above one here. Anyone who can help me, please?
There are some in the chat. I think someone just put it in the chat.
Okay, let me see what we have in the chat. In the chat, 8i2, good, excellent. But I cannot open the chat box every time, so please use your mic or anyone else can help me. So for 8, it will be 8i1. So what about 5, the voltage drop in the 5 ohm resistor? So in the chat box, it says nothing. It says, okay, because I need to click the mouse and to go to the chat box, so it is not clear in front of me. So anyone
that
can
would be
go ahead, please.
5 times
5 times
I2 minus I3
I2 minus I3. Thank you so much.
and
And
plus
plus
4I2.
4I2, and this is equal to 0, right? So as you see here, we have I3 in the second equation, but I3 is already known, So once I plug here -16, then I will have 2 equations with 2 unknowns. So let me rewrite these 2 equations. So for if I do rewrite them, so I will have 11I1 minus 2I2, and this will be equal to 30. So let's have a look from where I have this number. So I'm taking 30 to the other side of the equation, so it will be plus 30. For I1, I have 3I1 plus 2I1, it will be 5I1 plus 6I1, it will be 11I1. And for I2, I have only this guy times 2, so it will be -2I2, -2I2.
Excuse me.
Now, go ahead, please.
I think we forgot for the second equation, we forgot the 2 ohm resistor. 2 times I2 minus I1.
Oh, yes, sure. We forgot it. So let me write it here. Thank you so much. Thank you. So we need to write plus 2 times what? 2 times what?
I2 minus I1.
I2 minus I1, exactly. And this is equal to 0. Thank you so much.
The 8i
Okay.
should be I2 in the front of that one.
4I2.
The 8 one. 8i.
8I2. Yes, right. And this is 8I2. Thank you so much. Okay. Now we need to collect the I1. So I have here only -2I1. You see? So then in the second equation, I have -2I1. And now I will collect the I2. So I have 8I2 plus 5I2, it will be 13, plus 4I2, it will be 17, plus 2I2, it will be 19. So it will be plus 19I2. And here, negative I3 is -16. So -16, it will be plus 16. Plus 16 times 5, it will be 80. If I take 80 to the other side of the equation, it will be -80. So I have 2 equations, and solving them, I can find I1 equal to 2 amps, and I2 is equal to -4 amps. Of course, you can verify the results by plugging them in the equations. So we have these results, and the examiner asked me to find the power in the 2 ohm resistor. So as you see here, the 2 ohm resistor, and I need to find the power in the 2 ohm resistor. So let me change the color. I will go back to the green, this one. And what will be the power in the 2 ohm resistor? So the power, it will be 2 multiplied by the current square, right? And the current square could be I1 minus I2 or I2 minus I1. It doesn't matter. So I will write here the power in the 2 ohm resistor. It will be equal to the current square. So the current is I1 minus I2 square, and times the resistor, which is 2 ohms. And the I1 is 2 minus 4, negative 4 square, and times 2, and this will be, so 2 plus 4, it will be 6, 6 square, it will be 36, and times 2, and this will be 72 watts. 72 watts. So if we go back to our presentation, let's see what is the power. We see that it is 72 watts. 72 watts. Okay, any questions, please? Any questions? Okay, so we are done with the mesh analysis techniques, and we solved 2 examples, but we still have time. We still have 15 minutes. So what I want to do is to discuss the examples that we didn't solve. So we solved this example. So let me go up. This example will be homework, right? This is 4-7, and we don't have anything above there. So this is homework. And we solve this example. So let's have a look at this example. So again, here, how many essential branches I have? 1, 2, 3, 4, 5, 6. So 6 essential branches. So BE is equal to 6. How many essential nodes? 1, 2, 3, 4. So essential nodes are 4. And then the number of equations will be 6 minus 4 minus 1, and this will be 3 equations. So we need 3 equations to write this. And here we see, of course, that we have one mesh here, we have one mesh here, and another mesh. So this mesh could be mesh 1, this mesh could be 2, and this mesh could be 3. So you can assign them as 1, 2, 3, or I1, I2, I3, or ABC, or IA, IB, IC, whatever you choose, whatever you choose. And as you see that all of them are directed in the same direction, and we choose the clockwise direction just to make sure that we are in the same page with the book, with the textbook. If you choose all of them a counterclockwise direction, it will be fine, because it will be as if you are multiplying the equation right and the left hand sides of the equation by -1. So it will be fine. But let's select all the time with the clockwise direction, so we will be in the same page of the book. So I don't have any problem to write this voltage. It will be -25 plus 6 I1 minus I3 plus 8 times I1 minus I2. So this will be the first equation. The second equation, I will start with this. So it will be 8 times I2 minus I1 plus 8 times I2 minus I3 and plus 5 I5 and plus 5 I5. And for this equation, it will be 2 times I3 plus 8 times I3 minus I2 plus 6 times I3 minus I1. So this will be the third equation. And as you notice that we have I1, I2, I3 unknown, and we have also I5. But we see that I5 is the same as I1. So we can say that I5 is equal to I1. So once you plug I1 instead of I5 in the second equation, you will have 3 equations with 3 unknowns, and then you can solve them. And the examiner asks you to find the V node. And as you see, V node is equal to 8 multiplied by what? What do you think? What is V node? 8 multiplied by what?
That is I1 minus I2.
I1 minus I2. But why is that? Why it is not
Because,
I2 minus I1?
sorry, it's because we're going from the positive terminal to the negative terminal.
Exactly, because we need to write the voltage from positive terminal to negative terminal. So the current which is going downward is I1 minus I2. So we need to look at the polarity. Exactly, thank you so much. So as you see, very simple, although we have also one dependent voltage source, you can solve this, and this is simpler than the one that we solved, because here I phi is equal to I1 directly, while in the lecture I phi was equal to I1 minus I3. It's not much complex, but it's the case. Okay, and we solved now this, and we discussed already this. So the last one, the essential nodes BE is equal to 1, 2, 3, 4, 5, 6. So we have 6 essential branches. The essential nodes are 1, 2, 3, 4. So although we have one node here, but it is not essential. So we have only 4 essential nodes. Then the number of equations will be 6 minus 4 minus 1, and this will be 6 minus 3. Then we will have the 3 equations. So you can assign I1, you can assign I2, and you can assign I3 in the clockwise direction. And we can, of course, let me magnify this circuit. We can, of course, write KVL for this second mesh. So I will start with this. It will be -6 because I'm going in the voltage rise. It will be -6 times I2 times 1 plus, sorry, -6 plus I2 times 1 plus 2 ohms times I2 minus I1 plus 2 ohms times I2 minus I3. So this is the KVL for the second mesh. But if I want to write KVL for the first mesh, I cannot, because I don't know what is the voltage between these two nodes. If I go to the third mesh, of course, I cannot also, because I don't know what is the voltage between these two mesh nodes, because we have a current source, and this current source is independent current source, the value of which is 2 amperes, and no matter what is the voltage across it. So what I need to do is to remove this current source. So I want to remove it, to ignore it, and to have this super mesh. To have this super mesh. And now let me go and magnify it. So if I go with this super mesh, I will start with this 2 times I3 plus 2 times I3 minus I2 plus 2 times I1 minus I2 minus 10 volts, and that's it. So we started from this point. So this will be KVL for the super mesh. Is it understood, please, for all of you?
Yes.
Okay.
Yes.
So I have now 2 equations, but I need a third equation. And the third equation will give you that current source. So what will be the third equation? The third equation. What will be the third equation? Who can tell me what is the third equation?
2 amps is equal to I1 minus I3.
2 amps is equal to I1 minus I3, and Travis is saying the same in the chat box, and this is correct. So 2 amps, the current in this direction, which is I1, 2 amps is equal to I1, and here we have an opposite current, so minus I3. So this is the third equation. It will be 2 equal to I1 minus I3. So this is the third equation. And as I told you, always the third equation will come from inside the super mesh or inside the super node if we are having a super node. So now you have 1 KVL written for this mesh, another KVL for the super mesh, and here is your third equation, and you can solve the problem. You can solve the problem. In the last 5 minutes, let's discuss this circuit. So again, we have what we have here. We have, as you see, let me write on the circuit. So I will, so the number of essential nodes, B essential is equal to 1, 2, 3, 4, 5, 6. So 6. essential nodes, then essential is 1, 2, 3, 4. Then I need 6 minus 4 minus 1. It will be 3 equations. Okay, now 3 equations. I will assign I1, I will assign 2, and I will assign 3. But immediately I can see that I3 is equal to negative 10. You see, it's as the example that we solved here. So immediately I can say that I3 is equal to negative 10. So why it is equal to negative 10? Because they are in opposite direction. So this is why we have negative. If the current source was directed to the right-hand side, then I3 will be equal to that current source, which is 10. But in both cases, this one and this one, you see that the current source is directed in the counterclockwise direction, not in the clockwise direction, which is the positive direction that we adopted in this class. So for this mesh 3, I don't need to write any equations. Okay, so let's look at mesh 2. So again, I see that I2 is equal to this current. This current, this is a current source, right? So I2 is equal to this current. So I can immediately write I2 is equal to this current, and this current is 2V over 5, right? 2V over 5. Okay, so what is V5? Let me magnify the circuit. And what is V5? Who can tell me what is V5?
I1 minus I2
I1 minus I2 times what?
times 5.
Times 5, exactly. So it will be 5 times I1 minus I2. Now let me write here, and it will be, let me rewrite it here. So I2 is equal to 2 over 5 V5, and this will be 2 over 5, and you said that it will be 5 times I1 minus I2, right? So now I can cancel 5. So I2 is equal to 2I1 minus I2, 2I2, right? 2I2. Am I right and correct? So I will take I2 to
Yes.
the other side. So it will be 3I2. 3I2 is equal to I can keep it. I will bring I2 to this side. So it will be 2I2 minus 2I1 minus 3I2 equal to 0. So this will be the equation as you see from the second mesh, and I don't need to write KVL. I don't need to write KVL. So the dependent current source, which is voltage controlled, helped me to have this equation. So what is the equation? Let's double check the equation. So I2 is equal to 2 over 5 V5, and V5 is 5 times I1 minus I2. So it's 5 I1 minus I2. We cancel the 5s. So it will be 2I1 minus 2I2. If I bring I2 here, it will be 2I1 minus I3 equal to 0. Okay, so this is my first equation. And this is my second equation. And actually, the first equation is the variable value. And you need to write 1 KVL for 1. And this will be negative 75 plus 2I1 minus I3 plus 5 times I1 minus I2. I3 is given as negative 10 amperes. So you will have two equations, 1 KVL from here, and this is the second equation. You solve it, you find I1 and I2. Okay, so here is our lecture for today. And I see that Travis, you said V5 is equal to I1 minus I2 over 5, which is incorrect, yes, multiplied by. You corrected that, but you need to make sure that you have I1 in minus I2 in brackets, okay? So yes, yes, I see that. Okay. So this is our lecture for today. So if you have any questions, please go ahead. If you don't have any questions, so see you next Monday with a new method of circuit analysis.
Yes, you so what was homework again?
The homework,
Yes, that you signed.
yes, this one, and it is already posted on the Teachboard.
Okay, thank you.
You understood.
Thanks, Professor.
Yes, please go ahead. Okay, you are welcome.